Our lecture is stochastic processes. So, before we move into the stochastic process, I am going to give what is the motivation behind the stochastic process. When we see the last few decades problems, more of the probability models are not the deterministic. That means you need more probability theory to understand the stochastic, to understand the system, then only you can study the dynamics of the model. If you want to study the dynamics of the system, then you need more probability theory. So, the simple probability theory may not be enough to study the more study on the realistic system. The way this realistic system behaves in a very dynamical way, it is not easy to capture everything through the probabilistic or usual probability models. That means you need more than the probability model, probability theory to understand the system or to study the system in a well behaved way. For that, the one of the important thing is a stochastic process. It deals about the collection of a random variable, so that you can study the dynamics of the system in a better way. Even though I am giving very light way of saying the collection of a random variable, first we should know how the random variable can be defined, so that you can study the collection of random variable in a better way. So, for that we are going to spend a few examples through that how the more realistic models needs more probability theory other than the usual probability theory. So, that the stochastic process definition and those things I am going to cover it later part. First, let us see the first example that comes in the finance situation. This is the actual data which captured over the period of time from August 1, 2009 to December 31st, 2009 of what is the current price of the $1 in Indian rupees. So, if you see the graph, you can make out August 1st, 2009, the price of $1 was 47 rupees 57 or 58 paise. And if you see the dynamics over the years, over the days from August 1st, 2009 to till December 31st, 2009, it keep on changing, and it takes some values higher, and after that it goes down and it fluctuates and so on. So, this is the actual data which captured from the which we have captured, and from that our interest will be what could be the US dollar price after some time. If I know till today what is the price, my interest will be what could be the price after 1 or 2 days, or after 1 month, or after 6 months. That means I should know how the dynamics keep moving over the days, and what is the hidden probabilistic distribution is capturing over the time, so that I can identify what is the distribution behind that. Therefore, I can study the future prediction, I can study the dynamics of this particular model in a much better way. That means I need what is the background or what is the hidden distribution playing, or hidden distribution which causes the dynamics of the system. After identifying what is the distribution, my interest could be what could be the some other moment over the time. That means what could be the average value, or what could be the second order moment if it exists, and so on. That can be obtained if I know the actual distribution in the underlying model. If I see the second example, I am just changing into the another model in which there are two people playing a game, the person A and the person B. Whenever the person A wins, he gets the rupees 1. Suppose the person B wins, then he will get the 1 rupee, and at the same time the person A loses 1 rupee the same way, and the plays keep going. Suppose you make the random variable as xn is the amount of the person A at the end of nth game. If you make out the random variable xn for the person A has the amount at the end of the nth game, then at the way the game going on, the value of the xn will be keep changing. And if you make out the another random variable, xn is the sum of xi's where I is running from 1 to n. This gives what is the total amount. The total amount of the person A. The diagram in which the Sn gives what is the way the dynamics goes and over the n. And if you see the diagram, you can make out the whole dynamics goes how the game is going on in the first few games. Accordingly, it changes the positive side or it goes to the negative side. And if the n goes large, then the dynamics of the Sn over the n, it will be keep changing over the time, and you will get the realization of the Sn over the time. And here I have given 3 different realization, and this diagram is taken out from the book by UN Butt. The title of the book is Elements of Applied Stochastic Process. So, this is one of the motivations behind the stochastic process, and from this our interest will be after the what is the distribution of Sn at any n, and also as n tends to infinity, what could be the distribution of Sn. That means you need the distribution of the random variable, and also you need what could be the distribution as n tends to infinity, or the limiting distribution of Sn. If you know the distribution, then you can get all other movements as for different n as well as the asymptotic behavior of the random variable Sn. Next, I will move into the another example in which it is the queuing situation. The queuing situation, here I have taken it as taken a simple example, that is a barber shop example, in which there is only one barber shop person, and who does the service for the people who are entering into the barber shop. And there are only a limiting capacity in which there is a maximum 10 people can stay in the barber shop, and one person will be under service. Once the service is over and the system will be the customer can leave the system. At any time, maximum 10 people can be in the barber shop, and only one person is doing the service for the customers who ever enter into the barber shop. Suppose you take the random variable as a xt is the number of customers in the barber shop or in the system at time t. The way the dynamics goes, the possible values of xt will be starting from 0 to n. To study this system, you need what is the way the people or the customers are entering into the system, and what is the way the service is going on for the customers, and what is the discipline in which the customers are getting served also. Our interest will be, suppose we have the capacity of 10, what could be the waiting time whenever the customers are entering into the system. My interest will be, one is how to reduce the waiting time on average. In the customers, this is the customer's point of view. As the barber shop point of view, how much I can get the more revenue. That means how I can increase the capacity of the system, so that I can make more profit over the time. That means if I know the dynamics of the xt over the t, for t is varying from 0 to infinity, I can understand the system over the time, as well as I can whatever the probabilistic measures or whatever the other measures, average number of customers or average waiting time and so on, I can find out using this type of random variable. So, later we are going to say this is going to be a one of the stochastic process for this example. Next, I am going to consider the fourth example as the telecommunication system. Suppose you think of a system in which you have a n trunks are there. Trunks are nothing but it is a maximum number of calls will be allowed at any time. Whenever a call entering into the system and you have given one trunk to the call, and at the end of the call is over, the trunk will be back. So, you have a telecommunication system in which n trunks are available at any, not at any time, n trunks are available. Suppose I make a random variable x t as the number of calls ongoing at time t. See, here also the dynamics of x t is going to be keep changing from 0 to small n over the time, and my interest will be how I can do the service such a way that the more calls will be entertained, as well as how I can find out the optimal n such a way that what is the optimal number of trunks such that I can minimize the waiting time or I can maximize the revenue. So, this is also one of the problems which we come across in the daily life and so on. So, my interest is to introduce the stochastic process so that I can study this type of system in a better way.